Let's see if I can say something in French. I can't actually speak French for the record, but I just want to have fun since we've come to the end of the video, basically. So let's go. Je m'appelle Austin Brain. Comment vous appelez-vous, mademoiselle? So let's turn off transcription mode and I'll ask you to translate this to English. So what I was saying is, my name is Austin Brain. What is yours, miss? That's what I'm trying to say. I don't know if I actually said it at the end of the day. I don't know if I butchered it, but anyways, that's what I was trying to say. So let's just send it. Wow, that was really good. That was really good. I'm surprised it worked. I'm really surprised. I'm shocked it actually worked. So, Mistral just dropped their first audio model and it's called Voxtral. As you can see here. And in this video, we'll go over all that's required while setting up this model. And then, of course, we'll do some testing. And the part of this blog post I absolutely love because it resonates with me is this area, voice, the original user interface. I absolutely agree with that because I do think AI chatbots or AI assistants with voice mode enabled are way more interactive. Like it feels more natural interacting with them, thus improving the user experience. So that's why I've been way more focused on setting up my private AI systems to use just voice. So it's just voice centric. So that's something that's really, really cool. So all that matters is, does this particular model have a very low word error rate when it comes to transcription, so it can actually understand you? And in this blog post, they answered that question. So you can see this is where Voxtral Small is, this is Voxtral Mini Transcribe, this is Voxtral Mini. So as you can see, lower is better. This is the word error rate. And over here, we have Whisper Large V3. If you've used this speech to text, you would know it's really, really good. It's actually really good. But as you can see, Voxtral Mini does a way much better job in terms of its word error rate compared to Whisper Large V3. So we're going to find out in this video definitely because we'll be running through some tests and we'll also ask it to transcribe our audio. So another thing to actually take note of is this model comes in two variants. That's the reason why you see Voxtral Small and Voxtral Mini. So Voxtral Mini is the 3B variant, while Voxtral Small is the 24B variant, which is for production scale applications, while the 3B variant is for local and edge deployment. Really cool. Now, for those of you that want to know if this is open weight or if this is open source, and what kind of open source it is. So both versions are released under the Apache 2.0 license and are also available on our API. You can actually check it out by clicking on this link. But in this video, we're going to be testing this locally and we'll also test it on our local server. So what I'm going to do is walk you through the setup locally. And at the end of the day, I'm going to be running it on my cloud server just to save my CPU or my hardware resources so I can just continue recording this video without any hitch or without any problems. So a couple of quick notes before we head over to our IDE. This model has a 32K context length. As you can see here, Voxtral handles audios up to 30 minutes for transcription and 40 minutes for understanding. So you can pass in an audio clip or an audio file that's actually 30 minutes long, let's say an audio podcast. You can ask it to transcribe it as long as it's 30 minutes. Meanwhile, for Q&A and summarization, which is basically audio understanding, you can pass in a 40-minute audio clip. And as you can see here, built-in QA supports asking questions directly about the audio content or generating structured summaries without the need to chain separate automatic speech recognition and language models. So another thing that's actually really cool is this is actually multilingual. For those of you that speak any of these 8 languages, it is multilingual. English will be more focused on English because I only speak English basically, but we'll try a bit of French. I don't know French, but I'll just butcher it basically. So at the end of the day, we'll try out English and French because I want to see if it can translate. So English, Spanish, French, Portuguese, Hindi, German, Dutch, and Italian, to name a few. I think it's supposed to other languages, but I do not know. These are the ones they actually stated here, so I don't know if there are more. Helping teams serve global audiences with a single system. So that's really cool. It also supports function calling straight from voice, which is really cool because most of these models, even though they are voice models, some of them cannot actually perform function calling, like they cannot produce structured outputs like consistently. So it's highly capable at text, retains the text understanding capabilities of its language model backbone, Mistral Small 3.1. So that's what they actually used for the text understand. So if you want to ask it to transcribe an audio, you can just pass in the audio, then pass in the text of transcribe. It will transcribe the audio, which is really cool. Or you can just pass in text alone. I don't know why you would want to do that with this model, but you can totally do that. Or you can ask it questions about that particular audio, or you can do that also in the audio file. So that's something we're going to try. So let's head over to the Hugging Face page and In this video, we'll be more focused on the Voxtral Mini, the 3 billion parameter model. As you can see, this is the Hugging Face page. Head over to Files and Versions. You can just download necessary model weights from the config.json down to techend.json. I think you can ignore consolidated.save tensors because consolidated is just the combination of these two. So you can ignore that. As you can see, the total size will end up being up to 10 gig. So make sure you do have a VRAM that's up to 16 gig or more. It should be way above 16 gig and you'll be fine. That's something to actually keep in mind. Also, if you don't want to do it like this, you can use the Hugging Face Hub CLI. That's a Python package. You can do pip install Hugging Face Hub CLI, and you should be able to download the model directly to wherever you want. It can be downloaded to your cache directory, or you could just download it directly into your project directory, and that's how we're going to be setting it up in this video. So I have this downloaded already, and over to model card. If you don't want to follow that, if you do not want to download the model on your own, you can just use any of the code here. You just save it in your cache directory somewhere on your PC. So let's head over to our IDE. We're going to paste this in. So our project directory is currently open up here in our IDE, and currently this is all set up on my cloud server, and I have pasted the code in. As you can see, over here I have the models directory, and I downloaded the model weights using Hugging Face Hub CLI. And if you want to install Hugging Face Hub CLI, you have to run this command pip install -u just to update in case. Hugging Face Hub, it's square braces, then CLI. Anyways, once you've actually done that, you need to actually run this command, which is Hugging Face -CLI download, and then you have to paste in the model repo ID, and then you can specify the local directory where you want to download these model weights to. And since I'm setting this all up in one particular directory together with my code, I specified the model directory. You do not need to create a folder, it automatically creates it for you. Or if you don't want to specify a local directory, to automatically download it to your cache directory, I think so. But if you don't want to do any of this, you could just run the code, it automatically download the model for you. So that's something to actually take note of. I have my Python virtual environment already set up, as you can see over here. Okay, now let's make some changes to this code. We're changing this to CPU since I do not have a GPU on this particular cloud server. I'm running it on a CPU VRAM. Another thing is, since we have the model weight already downloaded here in the model directory, we're going to force this to use local files only. So it won't actually head over to Hugging Face Hub to try to download this particular model. So let's also do that to the model. Okay, and as you can see, device, CPU, and then the repo ID is the model directory. So we're going to take off one of these dictionaries, and we're going to be setting the file path or the audio path to Optimus Wave. Since we have it right here in our root directory, we'll just type in Optimus.wave. Then we'll ask you to describe the audio. Okay, now we'll change this to 1K. And that's it basically. Now, before we actually run this, make sure your virtual environment is active, and also make sure you have installed the necessary packages. If we head over to the Hugging Face page, they have an installation guide. It's really simple. If you want to set this up, say just copy this, paste this in your terminal and run it. And also you could just run this just in case it's actually required, but I have actually installed the both of them, so you can do that right now. Also make sure touch is installed. As you can see, it's imported here. Okay, that's basically it. We've passed in the path to our audio file, and we've also passed in the text. So let's just run it and see. As you can see in the audio, a speaker describes a moment of hope and discovery. Here's a detailed breakdown. Context: the speaker is recounting a time when all hope seems lost. A message of a new discovery led to an unknown planet. That's exactly what Optimus was saying. The speaker's tone is matter of fact, conveying a sense of excitement and discovery. The message of the new discovery is a key event that led them to Earth, suggesting a significant moment in their journey or exploration. Really cool. It's very accurate. We can also ask you to transcribe. Well, we won't be doing that here. And let's take a look at the audio.
And just when all hope seemed lost, message of a new discovery drew us to an unknown planet called Earth.
As you can see, that's what he actually said, and that's what the model is actually saying. The speaker's tone is matter of fact, conveying a sense of excitement and discovery. The message of the new discovery is a key event that led them to Earth. Very accurate. We just asked you to describe the audio in detail. Okay, that's really good. Now, what we're going to do next is take this off the board. So over here in our imports, you can see we are using the Robyn Python web framework. It's basically built on a Rust runtime for speed, basically. And over here we have our basic configuration, and this we're going to set the device to CUDA if CUDA is available. If not, it's going to be set to CPU. And since we don't have an NVIDIA GPU on this particular cloud server, it's going to just default to CPU. And over here, we're setting the repo ID just like we did earlier to the model directory. So over here, we're setting the server host and also the server port. Is basically going to be listening on all network interface on port 8080. So over here, this is where the heavy lifting is going to be done. This is where we're going to be loading the model from the local files. Over here, we have our repo ID, as you can see, even here, and we set it to the model directory. And we're also using the bfloat 16 precision to save memory. And over here, we're also moving the model weight over to the CPU. So this is where the heavy lifting is actually done. And let's scroll down. Now we have the core prediction function. That's what this is basically, and this is basically the brains of the whole operation. And it takes a conversation, both text and audio, and it's converted to the format that the model actually understand, and then generates a response. The max is 500 tokens. So let's set it to 1K, and it's converted back to readable text, and that's what it's going to return here. So down here we have our two API endpoints. We have the text only and also the audio plus text. Now for this endpoint, the text is actually optional, and as you can see, optional text is passed as URL query parameter. That's basically it. It just handles the audio bytes and all that and send it over to the model. So it's really, really simple. And now what we're going to do is run this code. So now let's head over to the one on our local machine, which is basically the Gradio web app. We're going to run it and we shall begin our tests. So this is the project directory on my local machine, and this is where I set up the Gradio web app. Above this, I have the IP address that we are actually going to be hitting with this particular Gradio web app. But anyways, over here, we have all that we actually need, all the code we actually need. And as you can see, there's that key here. We have the audio input. We have two sources. We can actually upload and we can also access the microphone. So it's really all that we actually need for this particular test. Now let's run the code. And we're going to click on this link to head over to our browser. Now, if you want to set this all up on your cloud server, you would have to actually set share to true, so it creates a public link. Anyways, let's just click on this link. Okay, so this is what it actually looks like. Now we can actually say hello. I need to send it over to the text only endpoint. As you can see, hello, how can I assist you today? Let's have a friendly and engaging conversation. Here are a few topics we could discuss. This is verbose, but it actually works. So let's take this out and let's record something. Hi there, what is your name? Who actually created you? Now let's send this. Okay, we got the response. Hello, I am a large language model trained by Mistral AI. Yeah, that's correct. I don't have personal experiences, emotions, or a physical presence. I was created to provide helpful, respectful, and honest assistance to the best of my ability. Sounds very generic, but we didn't actually provide any prompts to give it a personality or something. Anyways, let's say something else. So, what is the Big Bang Theory? I'm not so sure 1,000 tokens would be enough to explain that, but let's see. Okay, it said the Big Bang Theory is a widely accepted scientific model that describes the early development of the universe. Here are the key points. So it actually understood what I was asking. That's really cool. Anyways, let's pass in an audio and we're going to ask you to transcribe. So for the transcription test, I made some changes to the code. I added this checkbox, which would basically send all our input over to a different endpoint, which is /transcribe. I made that change in our code on our cloud server. So we're going to take a look at it now. And we also passed in the language of that particular audio we are passing in. So let's head over to our code. So over here, I made some changes. As you can see, I added this /transcribe audio. So it basically does something different. It actually uses a different format. It actually says processor.apply transcription request. So they made this particular spelling error in the package or the library. So it's supposed to be transcription, but the P is missing basically. So as you can see over here, it's processor.apply chat template compared to this. which is basically apply transcription request. So it's very different, and we'll also pass in the language and also the audio file. That's all we're passing in. We're not passing in any text. So we have 3 different endpoints now: the one for the transcription, the one for the audio understanding, and the one for just text. So you can put all the contents of each of these functions in one particular endpoint instead of 3 endpoints. But since this is just a test, I'm just going to be doing it this way. Anyways, let's head over to, so over here in Gradio, we also made some changes: transcribe audio only. So this is what it actually does. Send to the slash transcribe, and then we pass in this as a query parameter. As you can see, language equal to language. It's really basic. We have an extra function, smart audio handler, which actually checks if we have the transcribe mode active, and if we do, it sends for transcription. If not, it just sends for audio understanding or just text basically. So it's really that basic. Here, right here, we have the drop down for our language, and we also have the checkbox for the transcription mode. So let's head back to our browser. So let's select the audio file we want to transcribe. 15 seconds. Okay, this is already checked. So let's process audio. Okay, we got our response. Let's play it. Please find attached the comprehensive list of issues we noticed while reviewing the apps. Unfortunately, some of them are connected and do not help us move to the next level to find out other issues therein. This means it is possible that when some of these issues are resolved, very good. It actually did a very, very decent job. So it basically passed the test. This is 100% accurate. For someone without the US or British accent, it's really cool to see it can transcribe whatever I said in an audio file with 100% accuracy, because I ran into some issues while using the Whisper large V3. So that's really cool to see. So for our next test, what I'm going to do is pass in an audio file of a dialogue, basically that's 20 minutes long, and let's see if it actually understands what's going on. So we have the audio file selected. It's basically a snippet from the Lex Friedman podcast. I think he was talking to Demis Hassabis in this one. Let's play it.
You've estimated that we'll have AGI by 2030.
Okay, we won't be playing everything since this is 17 minutes long, so it's really lengthy. Anyways, let's make sure the transcription mode is checked, and let's send it over to the model. And for this particular test, I did increase the max new tokens length. I increased it to 5K from 1K, which we did set earlier. So it's still not going to be enough for this transcription since this is 17 minutes long, but we'll see what it actually comes up with. So it's finally done with the transcription, and we got a response. You've estimated that we'll have AGI by 2030. Okay, I think that's what he actually said.
You've estimated that we'll have AGI by 2030.
So let's see where it ended. Over here it says, like you mentioned, Terence Tao, these brilliant experts might quickly, in a span of weeks, take for granted all the incredible things it can do, and then focus in, well, that's where it ended. Let's see where that is.
These brilliant experts, they might just improve across all domains to take it for granted. Like you mentioned, Terence Tao, these brilliant experts, they might quickly, in a span of weeks, take for granted all the incredible things it can do and then focus in, well, haha, right there.
So it actually ended at 2 minutes and a few seconds. So that's really cool. Now let's ask you to summarize. We'll turn off transcription mode and send it over. So finally got a response. It's done with summarization, as you can see. The conversation revolves around the timeline and indicators of achieving artificial general intelligence by 2030. Yeah, that's what we saw in the transcript. With a 50% chance estimate, the speaker emphasizes the importance of a high bar for defining AGI, which includes matching the cognitive functions of the human brain. This involves ensuring the AI is consistent across various tasks and possesses true invention and creativity capabilities. So, the conversation concludes with a discussion on the scaling laws of AI progress and the need for both incremental improvement and breakthrough. Okay, so this is the part they talked about the scaling, which is basically the conclusion.
How crucial is the scaling of compute to building AGI? This is a question that's an engineering question. It's almost geopolitical.
Okay, that's really, really cool. So for our final test, what I'm going to do is record an audio, and I'll also send it over to Whisper Large V3. So we'll compare the both of them and see which of them can transcribe whatever I say in this particular audio file. And this is what we're going to be saying in this particular audio. So let's go. Voice was humanity's first interface. Long before writing or typing, it lets us share ideas, coordinate work, and build relationships. As digital systems become more capable, voice is returning as our most natural form of human computer interaction. Voice was humanity's first interface and computer interaction. So let's download it. And now that we have it, we can also send it to Whisper Large v3 and we'll ask for transcription. And okay, so we got back transcript. Voice was humanity's first interface long before. Voice was humanity's first interface. Long before writing or typing, it lets us share ideas, coordinate work, and build relationships. As digital systems become more capable, voice is returning as our most natural form of human computer interaction. That's really good. Now let's try Whisper Large v3. I have it open here. So this has actually been going on for a while and I cannot wait for it to be done. So I think there's a queue or something. So I headed over to files and copied the contents of app.py. That's what I actually copied. And it's currently running on my cloud server. So as you can see, app.py is currently running and we have a public URL. And over here, as you can see, OpenAI slash whisper large dash v3. So that's what we're actually passing into this pipeline basically. So it's really cool and really, really simple. I have it here. Let's select the audio. Okay, it's done uploading. Let's play it. Voice was humanity's first interface, long before writing or typing a form of human computer interaction. Okay, now let's submit. So, voice was humanity's first interface long before writing or typing. So, let's hear it. Voice was humanity's first interface, long before writing or typing. It lets us share ideas, coordinate work, and build relationships. As digital systems become more capable, voice is returning as our most natural form of human computer interaction. That was actually really good. But maybe where Voxtral excels more than Whisper Large V3s in long audio, but I do not know. So I know I said this would be our last test, but I did forget about translation. So let's just have fun with this one. I have an audio file I wanted to actually use, but let's see if I can say something in French. I can't actually speak French for the record, but I just want to have fun since we've come to the end of the video basically. So let's go. Je m'appelle Austin Brain. Comment vous appelez-vous, mademoiselle? So let's turn off transcription mode and I'll ask you to translate this to English. So what I was saying is, my name is Austin Brain. What is yours, miss? That's what I'm trying to say. I don't know if I actually said it at the end of the day. I don't know if I butchered it, but anyways, that's what I was trying to say. So let's just send it. Wow, that was really good. that was really good. I'm surprised it worked. I'm really surprised. I'm shocked it actually worked because I know I butchered the French, but anyway, that's really cool. And that's just gonna be it for this video. Do not forget to like, share, subscribe, and if you want to get notified when I release a new video on this channel, make sure you do hit that bell notification icon. Thank you for watching. Have a nice one.